Now you know what a paper computer is. Why would you want one? Well, I think it's about visualization. So the way that our minds work, a lot of it, not everyone's mind works this way, but a lot of people's minds work, is they visualize ideas in their head, and that's how they understand them. For example, the ancient Greek mathematicians and philosophers would imagine relationships between numbers, and they came up with geometry. They were able to draw circles and lines and intersections, and you get things like Pythagoras' theorem. You get ideas like a squared plus b squared equals c squared, which, if you say it that way, is really hard to remember. What does that mean? But if you were to diagram it out, you would see that it makes a lot of sense. And we're kind of missing that with computers. When you sit down with a computer to learn about variables and indexes and elements of different types, you don't have a lot of visualization. You're looking at code, which is a representation, but not a visualization. So that's the first reason. The second reason is that coding, once you really get into it, comes with a lot of complications because of how computers work and the history of computers. So some computer languages have you manage memory. Some computer languages manage memory for you. Some computer languages have very strict typing and have you declare variables, and others you don't need to. And some computer languages use a lot of abbreviations and symbols, and others kind of write things out. All that complexity, I think, can get in the way of learning, because the algorithms, right? Here's a good visualization of an algorithm. This is the Fibonacci algorithm, right? This visualization of the loop, of the starting and the finish, that can be really hard to see, especially if you have to deal with all the complexities of a computer language like JavaScript or C or C++, and you have object-oriented programming, you have functional programming, you have procedural programming. It gets complicated really fast, and human memory, the working memory, the learning memory is limited, and you can get distracted and lose sight of the algorithm itself, the concepts of the computer, because you're so busy worrying about the concepts of a computer language, of a computer keyboard, of a computer screen, of a window, all that kind of stuff. In here, we just have the cards, and they kind of visualize a computer. The other cool thing about the paper computer is that you use your hands to manipulate it. And, we know that a lot of us learn by doing. Again, not everybody, but a lot of us learn by touching and feeling and using all of our senses. Can't really smell the cards, but you can see them, you can feel them, you can play with them. So, for example, when you're following an algorithm and you're using your hands and your eyes along with your mind, it reinforces, it helps you build stronger neural connections. At least that's the theory. And when you were a kid, and maybe you still are a kid, maybe especially as a little kid, you might have played with toys like blocks or Legos or Lincoln Logs, and you learned concepts you probably didn't even know you were learning by trying to build the model of a house or the model of a building or a car, right? And then those concepts helped you later in life when maybe you had to, think spatially, think about how things are put together, or how you can take things apart and put them together in different ways. So those are the three reasons the paper computer is a good idea, and why, when you're just getting started in computer science, the paper computer helps you focus. It's visualizing some important parts, not the only parts, but important parts of a computer. So that's the first thing. And then you don't have to deal with the complexities of a programming language. We do have a language that we call Card Basic, but it's just basic English. It's just English sentences that are sort of arranged the way a computer program would be. And in another video, we'll go over Card Basic. And then finally, you're learning by doing in sort of a multimodal way with your hands, with motion, with your eyes, and with your mind. So those are the three reasons that a paper computer is a good idea. And I would suggest that you start out with the kit. What you want is the starter kit. Well, here, let's move this out of the way. So you have Card Basic Deck 1 and 2. You have the paper computer deck. And then you have the Hello AlgoMaps workbook. And the workbook is a guide and has worksheets. So the guide gives you a good introduction to computer science, how to think like a CPU, and then a brief introduction to the paper computer, and then it has these worksheets. And the worksheets are good because they're sort of a visualization of the loops and branches. And we'll have a separate video where we go over this. We have an output record and an iteration log. So this way you can just follow along in the booklet. You can use Card Basic. You can do the basic algorithms. There's 14 very simple basic algorithms. You kind of build from there. One of the things that you learn is that you can merge several algorithms together to do a complicated task. And the other thing you can do is you can improve algorithms. You can make them more efficient and more effective. And you got to start simple, and then over time get more complicated. So that's why you want to buy the complete kit. That's why you want to buy a paper computer, and this is what a paper computer is. Anyway, we'll have more videos to explain the rest of it, but I just wanted to kind of get this out there so you understand what you can do and why you would do it with a paper computer.